Alright, this is the notes for section 9.8, natural logarithms. If you haven't done so already, make sure you pause the video at this time and read section 9.8 before continuing on with the video. So we've talked about common logs where the base was 10. Then we said the log can have really any base as long as it's greater than 0 and not equal to 1. Well, one logarithm that's used quite a bit is the inverse of y equals e to the x, okay? And that's what we call the natural logarithm, okay? And here's the definition of a natural logarithm. N is the natural log of m, written n equals the ln of m. Now that's the key part here, is that although it's a logarithm, we don't actually use the word log when we write it. We say ln standing for the natural log, okay? So if and only if m is equal to e to the n. So what we need to realize is that when I'm saying ln of m, that's like saying the log base e of m. Okay? So it just means that our base is e, we're taking the log of m, and the exponent is n. Okay? So let's take a look at example 1 here. It says estimate the following to the nearest thousandth using a calculator. So really the key to this is being able to use our calculator to find the natural log. And there's a natural log key on our calculator. Since the natural log is the inverse of e to the x, and we'll talk a little bit more about that in just a little bit, the calculator key that we're looking at is this key right here, e to the x. Okay, so it's going to be control and then that key. So control e to the x, and that brings up ln, and then we just put in 325. So that's what we want to find the natural log of. And then if I hit just enter, it's just going to give me the same thing back. But if instead I hit control enter, it's going to give me the value that I'm looking for, which would be this 5.78383. Now, the problem asked you to give your answer to the nearest thousandth. So when I write my answer, it's going to be approximately equal to 5.784 if we round that to the nearest thousandths. Okay, and then why don't you try the ln of 8 as well. So go to your calculator and enter in the ln of 8. If you do that on your calculator, you should get 2.079, and that's what I have on my calculator here. So that would be the answer to part B of that one. So just like any other log function, remember that the log function is always the inverse of the exponential function. So the graph of y equals ln of x, since in a natural log the base is e, y equals ln of x is going to be the inverse of y equals e to the x. So if I graph those two functions on the same axis, there'll be reflection images over the line y equals x here. So here's the example of y equals e to the x, and here's the reflection image of which is y equals the ln of x. You'll notice that if I look at t-tables, for any ordered pair that I have in this function right here, the inverse of it I have over here in this set of ordered pairs. Okay, so the x and the y will always switch, and when I look at the inverse of any function. Okay, let's take a look at example 2 here. Well, both examples 2 and 3 look at some applications of the natural log. It says in number 2, it says, ignoring the force of gravity, the maximum velocity v of a rocket given by the formula v equals c times the ln of r, where c is the velocity of the exhaust, r is the ratio of the mass of the rocket with fuel to its mass without fuel, With a small payload, a solid propellant rocket could have a mass ratio of 19. A typical exhaust velocity for such a rocket might be about 2.4 kilometers per second. Find the maximum velocity of the rocket. Okay, so really what we're looking for V. So as I look at this formula, we're looking for V. So I really just need to know what is C and what is R. Well, R is that ratio, and it says the mass ratio is 19. So that's the value I'm going to put in for R. Okay, 2.4, that represents the exhaust velocity, which is C. So I'm going to put that value in for C, and I'm going to solve for V. So V is equal to 2.4 times the ln of R, which is 19. Okay? So to find that, now I'm going to go to my calculator. So I'm going to enter on my calculator 2.4 times the ln of 19. And if I hit Control Enter, because I want an approximation here, get me the approximate value, I get 7.06665. So if I round that to the nearest tenth, that's about 7.1 roughly to the nearest tenth, that is. So I'm going to come over here and I'm going to put that in as my answer, 7.1 for that velocity, and that would be in kilometers per second squared for our units. So let's take a look at number 3 here. It says the wind velocity v at a height h centimeters above the ground is given by the formula v equals k times the ln of h over h sub 0, where k is a positive constant that depends on air density, average wind velocity, and other factors. And h sub 0 is a roughness value depending on the roughness of vegetation on the ground. Okay, so we have this formula, we know a little bit about each of those variables. So really as we do this, what we want to do is plug in the things that we know and solve for what we want to find. So in part A it says suppose h naught is 0.7, or h sub 0 I should say is 0.7, a value that applies to the lawn that is 3 centimeters high. Therefore h would have to be 3. If the wind velocity is 435 centimeters per second, so there's your velocity v, what is the value of k? So let's start with our formula. V equals k times the ln of h over h sub 0. Now I'm going to plug in what I know. Well, I know the velocity is 435. I don't know what k is, that's what I want to find. And h is 3 centimeters, and h naught is 0.7 centimeters. So I have everything that I need for that one to kind of continue on here. So now what we want to do is we want to solve this for k. Well, if I'm going to solve this for k, I need to get k by itself. Remember, this means k times this. So to get that by itself, I need to divide by the ln of 3 over 0.7. Well, if I do it there, I have to do it here as well. Okay. So on this side, this cancels out, and we're left with just k. And now this is the stuff that I'm going to put in my calculator. So I've entered that into my calculator, and I want to get a decimal approximation to this, so I'm going to hit Control Enter to get my value, which is about 298.91. So if I round that off, that's about 299 would be the value of k, and that's what I was looking for there. Okay?